Alright, so let's get into some of our reactions here. So the reactions are actually pretty interesting in this chapter. First reaction is alkylation of acetylide ion. So this is actually a fairly straightforward reaction. It only has one really new step in it. So I'm just going to write here that the products of this reaction are going to be E2, right, plus or minus SN2 products. So, insert chapter 6 stuff in here. Let's look at the reaction. So if we come down here below, let's start off here with, how about CH3, C triple bond H. And what we'll do for our first step here is add, and this is the way you guys will see this, NaNH2. But remember, that's really just grabbing the amide. That's what we want there. So this is just an acid-base reaction here. So that's our first step. CH3, triple bond carbon there. Now this is just a nucleophile, right? So this is a nucleophile / base. So what happens next depends on what type of substrate we have. Right? So in other words, what do we react with this? Well, let's look at one extreme here. So CH3I. Right? So if we do that, then we see SN2. Right? We swing around here, and we would do that. So this is a very important reaction because we're gaining a bond to a carbon atom. So it's one of the first reactions in which we've seen that we can grow molecules by adding carbons to each other. Right? So it's a really important thing. So here, highlight to yourself that we have a new carbon-carbon bond. So we're going to see coming up here that this type of reaction is important in something called multi-step synthesis. And we'll do a little lecture on that. All right, so we could also take this guy and we could come down here and we could do, something like this. All right, so if we did something like that, we have the potential to form two products. So this is a secondary, right, alkyl halide. So this is, if you remember back in chapter 6 and 7, it's a kind of a gray area on some of the products. So you're going to get elimination and you're going to get some substitution in here. So your elimination product here is going to be this guy. So when you get that, by the way, you also will form, oops, sorry, let's get rid of that. You will form this, so that's what grabbed an H, right, your acetylide ion. And then we could do a substitution. The substitution here would give us essentially our carbon, right, connected now to 1, 2, 3, this guy here. So this would be your E2, that would be your SN2 product there. Right, now let's take a look at the next reaction here. It's really just a continuation of this same idea. We're going to take an alkyne. NaNH2 makes the acetylide ion out of the alkyne. And then we're going to add here as our electrophile a carbonyl, which will be an aldehyde or a ketone. So let's take a look. So here's NaNH2. Right, so put in your lone pairs there. So again, to reiterate that first step, we're doing that. Now that's going to give us CH3, C triple bond, C minus. Now what we add to this next needs to be an aldehyde or a ketone. So we're looking at aldehydes here. Let's just pick one. So how about this? This is acetaldehyde. Now, when this nucleophile comes over and reacts here, it's reacting with the pi bond. So it's the pi bond that reacts. Now, if you remember from chapter 7 and chapter 8 actually, the pi bond can react at both faces. So in other words, this carbon can come over and react at the p orbital that's pointing out towards us. Right? It's kind of hard to show that here, or it could react to the p orbital that's going behind us. Okay, so if it reacts with the p orbital that's in front of us, it's going to push the oxygen going backwards, right? So we're going to get, I'm going to go to line structures here, 1, 2, 3, this. And now I want to put a little bullet right here, because that bullet's this carbon. So that oxygen can go forward or backwards. So it can be pointing out at us, right? And then I'm just going to swing this guy around and make it flat, and the H would be there too, right? So then the H would be here. And we also can get its kind of partner, which would be 1, 2, 3. Oh, sorry, O minus. Got a step ahead of myself there. O minus and H. That's the hard step there, right? So the next thing we do is that acid workup. So that's our step number 2. So in lab, we'd have to separate these out and sequentially add, step 1 and step 2. So step 3 is your acid workup. So we add H3O plus there. Right, so take a second, go ahead and see if you can finish that, catch up to where I am. And then I'll just show this last step here on one of them. It can occur, it does occur on both of them, right? So we're going to get this guy, and you don't need to put the H in there anymore if you don't want to, plus that guy. You get these two products. So we have a new chiral center that's formed there. Okay. Now when we add it to a ketone, it's not different. The only thing with a ketone is that rather than have like an H right there, you're just going to have another R group. So this is the same reaction really. But let's see if you guys can do it down here below. So again, Na and H2. Put those lone pairs in. And then let's grab the H and do that. That gives us this guy. And then and let's add acetone to this. So the way that you would see this, maybe combining things, is step 1, Na and H2. Step 2, how about acetone? Step 3, H3O plus. So we just did step 1. So step number 2 here is that acetone. And we just need to know that this is going to come in here and it's going to react at this carbon. Now, is that going to be a new chiral center? Well, the methyl groups are the same, so it's not going to be chiral in this case. But it could be, right? It just depends on what those R groups are here. But because they're identical, we're not going to end up with 4 different groups here. So it's going to be 1, 2, 3, and then that little bullet is this guy, right? So those are the same atoms, and then we're going to have here an oxygen with a minus charge, and then the last step is your acid workup, right, with H3O plus. So right, last step is we're just going to grab that hydrogen there. So let's come over, grab it and do this. And that gives us our final product here, which is a tertiary alcohol. And again, just to point out that bond right there, that is your new carbon-carbon bond. So that's an important reaction. We're going to see an example of why that's important when we look at the multi-step synthesis.